let it bang, bang.
Now the only step remaining is to write the recursive function or the divide function, right? So we will write it. We will name the function as MergeSort, and here we have to pass parameters like mylist. Then we have to give the left index and the right index. So now we have to check that the list at least contain two elements to divide it. So if it contains one element, then we do not have to divide it. So we will done this by writing this condition: if left index is less than right index, and then we will calculate the middle one. So middle calculation will be done in this way: left index plus right index, and then we have to do the integer division. Now we will as we are dividing it, so we have to call this function recursively. So we will write merge sort and the mylist left index and then the middle. Then we have to write the middle, and from here we will give the mylist, and division will be and the division will be middle one and the right index, right? So our list will be divided into, by calculating the middle, we are dividing our list and calling the merge sort function again, right? So now only step is to call the merge function. Now as the lists are completely divided, we have to only call the merge function to merge it. So we will do it by giving some parameters. Okay, so first we will give the mylist, as it is in place sort. So don't think that the list is not dividing. It is dividing, just the indexes are changing. So index, by the index we are dividing the list. Okay, the original list remains same, but the indexes divide the list. So here we will pass the left index, the right index, and we will also pass the middle one. So in this case our merge sort algorithm will work accordingly. So middle element here, middle means is that every step as we reach from here to here, so we have to make track of the middle position. So if we keep track of the middle position, then we will know that yeah, the original sublists are possible here. So we know that where these lists are sorting, as it is a in place sorting algorithm. That's why we have to keep track of the middle element from here, from here, from here. Yeah, so original list is not changing, only we are doing it with the help of the indexes. So now let's check it if it's working properly or not. Now before we run it, we have to make some few changes because they can cause error. For example, here we have not separated the middle element of the two lists. Here it will be made common, so both elements will be in the different list. So in this list we have to do middle plus 1, and now as we are passing here index, so we have to do -1 here in the calling. And the last change we have to do here in this merge function, uh, we as index slicing works by ignoring the last element, by excluding it. So we have to +1 here, and as the middle element, it is in the first division, it is available in the first division, and in the second it is available in the second division. So we have to in order to include it, we have to do +1 here in the listing itself, so that middle element will be included here. So now we are completed. Now we can just run our code. Yeah, now we can see that our index is sorted, list is sorted. Now let's take some another list, 10 1. Let's see if it's sorted or not. So yeah, we can see that it's sorted. So in that way we can give different elements. Now we don't have to give them in a separate order. So this is how MergeSort works. I know this may be a big lecture, but after you have implemented it, there will be no confusion in it, right? Okay, thank you. See you at the next lecture.
Let it, let it, let it, let it, let it, let it, bang, bang.